Hi everybody. Welcome to the video for Cumulative Review Packet number 11. I'm going to start here with number 7. So number 7 asks us to find all the zeros of this higher order degree polynomial. This starts with x to the 4th. And I'd like to point out that because this has 1, 2, 3, 4, 5 terms, we don't really have a way to factor this. We can't do grouping. We don't have any tools in our toolbox. So we have to rely on the rational root theorem and synthetic division to reduce the degree of this polynomial from to the 4th to maybe to the 3rd. Then we can continue it either with synthetic division or grouping. So first what we want to do is find all possible rational zeros. And to do that, it's really plus or minus p over q. So all the different possibilities. P represents 84, and q is the number in front of x to the 4th, which is 1. And so what we need to think about is all the possible factors of p. So the numbers that can multiply to be 84 are 1 times 84, 2 times 42, 3 times 28, 4 times 21, 5 does not go in, 6 times 14, and lastly 7 times 12. So these are all the options that can multiply to be p. The only options that can multiply to be q is just 1 times 1 or 1. So technically I could divide all these numbers by 1, but it would be all these answers anyway. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 2, 24 possible roots. Now, again, as some of you recognized in class, writing all of these can be helpful, but sometimes it's good to rely on your graphing calculator and to look to see where it crosses the x-axis, and then going back to see if it would make sense with this list that you wrote. Now, on this first test, Mr. Bocconi and I will be looking for this to see if you understand where this comes from, but as the semester goes on, we're going to get away from the plus or minus p over q. So let me go to the graphing calculator, because I've already graphed this. And if I take a look at this, I already put the function in over here. You can't see it completely. But when I graphed this polynomial, and feel free to pause and do so, and I would like you to see on your graphing calculator if you got the roots of -3, 0 and 7, 0. So these are two possible roots. Now you might notice that your original function, if I go back to the original, is x to the 4th. And yet in my picture, I only see 2 rational roots, which means 2 of my answers may be imaginary. So when we start this process of reducing the degree, we could either start with the root -3 or the root +7. And I will choose to start with -3. So I would do synthetic division. I would put -3 in my box, and I would write the lead coefficients of 1, -4, -17, -16, and -84. And I'm hoping if this is truly a root, we can prove that by getting the remainder here to be 0. So I bring down the 1. 1 times -3 is -3. Combine down, get -7. -3 times -7 is 21. 21 minus 17 is +4. -3 times 4 is -12. Combine these is -28. -28 times -3 is a +84, and that's extremely convenient because my remainder is 0, which means this is for sure a root. We've proved that algebraically. And so at this point, you can continue this problem one of 2 ways, and I will do both because, again, you have a choice. There's some of you out there that already know from the picture that another root is 7, 0. So what you could do is do synthetic division again, but this time put 0 in your box, and you would not continue from the beginning of the problem, but continue from where you left off. So you could write 1, -7, 4, -28, and you do not need to write the remainder of 0. And you could do synthetic division for a second time to reduce the degree from x to the 4th. This reduced it to x to the 3rd, and now this would be x squared. So I bring down the 1, multiply, combine, get 0, multiply, combine, multiply, combine. So I again get another remainder of 0, which is excellent, which proves this is another root for sure. And I'm left with this polynomial. This is now x squared plus 0x plus 4 equals 0. If I continue to solve this, I would get x squared equals -4. And if I take the square root of both sides, we are going to get imaginary answers, specifically plus or minus 2i. So if I did the problem this first way, my answers are going to be negative 3, 0, 7, 0, 2i, 0, and lastly, negative 2i, 0. Now let's say that you preferred in class doing the factoring by grouping. So let's say you started the problem the exact same way. You like to start with negative 3, and you did synthetic division to reduce the degree. So I'm going to do the exact same thing again. I'm going to do synthetic division, same process. And yet again, I get the remainder of 0. But instead of doing synthetic division for a second time, some of you might look at this polynomial and say that this is really x to the third minus 7x squared plus 4x minus 28 equals 0. And you might want to continue with factoring by grouping. If you do so, you should get the same final answer. Let me show you. The GCF here is x squared, and you're left with x minus 7. The GCF here is 4, and you're also left with x minus 7. So if you factor by grouping right here, we have x minus 7 as one factor, and x squared plus 4 as the other factor. If you set both of these equal to 0, x minus 7 equals 0, so x equals 7, which is something you got from the graph earlier, but this proves it algebraically. I know Mr. Marconi and I both do like to prove it this way. Then if you set x squared plus 4 equals 0, you'd have x squared equals negative 4, take the square root, and you get x equals plus or minus 2i, which is the same as what I did in the first method. So we will accept either one of these methods on the test. From class, it seemed like more of you liked method number 2, but method number 1 is an option, especially if you're able to see 2 roots from the original problem. That's why the graphing calculator is powerful. Based on the zeros above, write the function as a product of linear factors. The word linear means power of 1, and product means multiply. So we want to write factors that are all linear and that you are able to multiply. So the original function was called f of x, so this I will call f of x as well, and it all has to do with my answers for my roots. So these are the answers that we got here. If I have the root of negative 3, that means it came from the factored form of x plus 3. The root of 7 came from x minus 7. The root of 2i is really x minus 2i. And then the root of negative 2i is really x plus 2i. So this would be your answer in factored linear form. If you multiply this out, none of these here would be linear anymore. Number 8, find a quadratic function in vertex form. Vertex form is y equals a times x minus h quantity squared plus k. That has a vertex of negative 5, negative 2. The vertex is always hk and passes through the point, which is always x comma y. So this problem you are plugging in backwards and solving for a. So let's see what we have. Y is 7 equals a times x is 4 minus h, which is negative 5 squared, plus k, which is negative 2. If I rewrite this a little bit, we have 7 equals a times, this really becomes a plus, 4 plus 5 quantity squared. Instead of plus a negative 2, I'm just going to write minus 2. So if we continue to solve for a, we're going to add 2 to the other side and get 9 equals a times 4 plus 5 squared, which is really 9 squared. So that is 9 equals a times 81, which I'll just write 81a. If we want to get a alone, we divide both sides by 81. And 9 over 81 reduces to 1/9, which means that my final answer would look like this. You want an answer in green. You want to plug in a to your final answer, and you also want to plug in the vertex h and k. But you want to keep x and y general. So we'd have y equals 1/9 for my a value times x minus h h again is -5, so that really becomes a plus 5 squared plus k, which is really -2. Final answer for number 8. Number 9 asks you to solve the polynomial inequalities. So what we're going to do initially is treat this like a normal factoring problem, but eventually we're going to find the critical numbers, which are really the same as roots, and we're going to put them on the number line and check to see if each region is true or false. So the first thing we need to recognize is that for part A, we need this equal to 0 in order to factor, or hope to factor. So if I subtract the 13 to the other side, I get x squared minus 4x minus 5 is less than 0. So if I continue to factor this side, we would have x times x is x squared, 5 times 1, so -5 times +1 is -5, and -5 plus 1 is -4. Which means that one critical number, or root, is +5, and the other critical number is, or root, is -1. So I come over here on my number line, and I would put these in appropriate places. I would put 5 over here, 4, 3, 2, 1, 0, -1. And so we really have 3 regions here, less than -1, between -1 and 5, and 5 to infinity. Because my inequality is just less than, on the number line, -1 and 5 are not included. So we'd put an open dot on each of these critical numbers. And so what we have to do is check each region. So I'm going to pick critical numbers, or x values, that are clearly in each region. Something that's way below -1 is like -10. Something between -1 and 5, the easiest number, is 0. And then something above 5, I will go with +10. And so what I would really suggest that you do is plug everything into this factored form, because I think it's the quickest way to check. We want to make sure that this side is less than 0. And so what if we took -10 and plugged it in here? If I took -10 and plugged it in here, that would be -15. If I took -10 and plugged it in here, that would be -9. I don't really care about what the actual number is. What I care about is that negative times negative is a positive. Is a positive number less than 0? No, that's not true. So this region is not true. If I take 0 and plug it into the factored form, we would get 0 minus 5, or -5. We would get 0 plus 1, which is +1, and my final answer would be negative. Is a negative number less than 0? Yes, it is. If I plug in +10 into my factored form, 10 minus 5 is 5. 10 plus 1 is 11. My final result is 55, or a +55. Is a positive number less than 0? No, it is not. So it looks like my only region that works is the one in the middle, and we want to write our answer in interval notation. Because -1 and 5 are both not included, we need to use a parenthesis and not a bracket. So my final answer is just between -1 and 5, both not included. Instead of rushing the example 9b to get this in 15 minutes, I'm going to stop this video here, and I'm going to do another video that's going to go from 9b to number 12. So please join me there. Thank you.